Okay, this is a demonstration of the heart rate variability procedure in NeuroField64. This demonstration is based on beta version 2.2.91. So let's get started here. I have my two X3000s, two TDCSs, a Q20, and an HRV hooked up right now. I'm going to start up the system, select myself as a patient, and we'll get going here. So you need to enable the units that you want to use when doing the procedure. You can use one or all of the stim units. So I'm just going to enable all of them. And there's a lot you can do here, but you want to basically choose the body for the EMF coils. Oops, there we go. Because everything that you choose here is going to be saved in the history. So you want to use these drop-down menus to let the computer know where you're placing things. So let's say I do FP1. Typically I don't use the ACS on the brain. I might use it on the body. So actually let's say that. Let's say we're working on a knee or something, or two knees. Okay. Now once I have my stim units all enabled and set up, I'm going to select a treatment protocol by clicking Select Treatment Protocol button, and I'm going to click the drop-down menu, and I'm going to go to, if you notice here, tables 26 all the way through tables 35 are part of the NeuroField database. So I've mixed together the parasympathetic and NeuroField protocols so you can give them simultaneously. But for the first step of this procedure, what you want to do is a screening of the NeuroField all frequency lows protocol, which is table 34. There's 7 protocols in that table. You can select it, then click on load, and it will load them in there. The idea here is to do a gross screening to see which one of the protocols the body wants, essentially. Once you load it, you click on Save Protocol and Continue. And then from there, what you want to do is make sure it's set to 1 loop, and then you're ready to go. Click on Save Stim Setup and Continue. And this next step, you want to enable the HRV. And at the top here, you just click on the little HRV button there, and the HRV controls will now be clickable. For device selection, it defaults to the HRV. Training metric is SDNN. You can train on amplitude if you want. This is for, in the original NeuroField procedure, Paul NeuroField used to use pulse to figure out what frequency the body wanted. And here we use, you can do that by selecting amplitude. The way I originally created the procedure, we used the standard deviation from normal to normal beat, which looks at the variability of the heart, and I tend to like that more. However, both of them work. The standard amount of milliseconds for the threshold is set at 10, and the amplitude is set at 10. Leave these numbers as they are. Defaults, we found they tend to work well. So your next step is to put the sensor on the person's ear, clean the ear. If you rub the earlobe a little bit, you'll get blood in there, and it makes it easier to pick up the pulse. So first thing you want to do is make sure that NeuroField has seen the heartbeat. So you'll see 2 buttons here. One is Start HRV Scans, and the second is Cal, which means Calibrate HRV Sensor. So I'm going to start the scans to make sure that we're getting a heartbeat, and I'm going to click on Start. And if you just wait for a second, NeuroField will pick up the heartbeat, and you'll start to see it displayed on the screen as it is now. Typically when you do this procedure, you don't want the person to talk. Have them breathe normally, swallow normally, and not to hold their breath. I usually have people close their eyes when we do this procedure. So you can see that we're getting a registered heartbeat here. So what I'm going to do is stop the HRV scans by clicking on Stop HRV Scans. And you have to wait for that cycle to end, and it will stop. Now the next thing we want to do is a calibration. I'm going to start this and I'm going to stop talking until it's done. Okay, it's all done. That's how quick it is. Now it says HRV calibration complete. It doesn't mean that it's correct. You have to verify that visually by looking at it. And the way you do that is you can see each one of the heartbeats in the first derivative here. And every time NeuroField detects a heartbeat, it creates what's called a hold off. And what this is it's telling NeuroField to hold off on looking for another heartbeat until it's done. So the hold off is for X amount of time, and then NeuroField looks for another heartbeat. And then you can see the hold off the left side of that rectangle will correspond to the heartbeat. And they should be evenly spaced apart and look just like this. This is a good calibration. We call the evenly spacing of the hold off the picket fence. So if you get a good picket fence, then you know you're good to go. So we're calibrated now. The next step is to set the HRV sample times. The pre-stim and post-stim are it's the amount of time that HRV is taken. Typically, you can do 4 seconds and 4 seconds and 4 seconds. If you want to populate the total power spectrum with relevant data, you need to take longer scans. And you can click on these and choose longer period of times, which will give you, again, higher resolution total spectrums. For the purpose of this video, I'm simply going to leave everything at 4 seconds. However, I do recommend that you set it at 64 seconds pre and 64 seconds post. It does yield a good deal of data. And the interstim time, leave it at 4 seconds. Otherwise, this procedure could take a very long time. But for just demonstration purposes now, I'm going to leave it at 4 seconds each. And we're all set and ready to go. So I'm going to click on Save Patient Settings and Continue. And then now we're taking to the Start screen. When I click on Start here, NeuroField will set itself up, and it will take a baseline, and then it will give me all 7 of the frequencies, and then it will take a post-test. So during this time, I'm not going to talk. I'm just going to let NeuroField do its trick on me, and then we'll come back and take a look at the data. Here we go. Okay, so we got a bad picket fence there. If you see this, you can see that the NeuroField caught a bad edge when the program started. So I'm going to stop it. And when you abort it, it'll open up this setup window. There's no data here because we didn't do anything. So now I'm going to stop. I'm going to cancel out of that. And I'm going to select my Nausea all frequencies low again, load it, save the protocol, save stim setup. We're all ready to go. We're going to take another stab at this. If you can notice here on the HRV spectrum, the baseline came up at 83.98, which is way, way high, and it's representative of an error. So I'm going to try this again. Here we go. Okay, so it just finished the scan, and as you can tell by looking at the HRV spectrum, there was two significant events. The 0 is the baseline, and then 1, 2, 3, 4, 5, 6, 7, and 8 are all the frequencies that are given, and then 9 is the post-test. So what you see here is that NeuroField said that that there was one hit, and it was 146 hertz. Now you have to get to know the Nogier frequencies, and in your NeuroField documentation folder, there's a PDF in there called Nogier frequencies. You can pop it up, and that's the last frequency. 146 is the cerebral cortex, and it's the last frequency in the Nogier set. So you can see here that the SDNN was very high, around 60 to 70, way above baseline. And the way it works is that we add 10 milliseconds to your baseline, and if the SDNN goes above that, then we say it's a hit. So 10 plus the baseline here, which is 10.24, is 20.24. Everything above 22.24 is considered valid. And so we had one hit that way. Now, you can also see in the amplitude, this is the on the top here, this is the RMS amplitude. You can see number 6 was also very high, way above the 50 baseline. And so we could look at that one too. Now, I was doing SDNN, so I'm going to go along with that. However, it is up to the user to select which one they want to screen. So now that I know what frequency caused a hit, I want to go back and do a finer resolution scan. So I'm going to cancel out of this window here. You have to hit cancel. And now it brings me back to the protocol menu. And this is where we want to load in the Nogier protocol that is associated with the cortex. And that's right here, the one that says cerebral cortex. I'm going to click on that and load it. Now, if you remember, 146 was the frequency that caused a hit in the initial scan. And you'll notice here, we start at 145.9 and we go all the way through 146.16. What this does is a finer resolution screening, because Paul Nogier said there was a plus or minus 30% variability in the frequencies. So that everybody's just a little bit different. So now we want to expose the body to these different frequencies and see which one it actually selects. So once you load in your protocol, you save protocol and continue. It's all set up for you again, so you just click Save, Set Up, and Continue. You've already set up everything here for your HRV, so you're good to go now. You click Save Patient Settings and Continue. We allow you to go through all this again just in the event that you want to change anything. And now we're all set and we're ready to go. Again, it's going to go through all the frequencies, and when it's done, it's going to show me if there's any hits. So I'm going to click on Start, and during this time I am not going to talk. Okay, it's all done. So now it's gone through the entire scan, and you can see the hits that were registered there. Visually in the table, you can see which ones were way above baseline here, and they're put in a table for you. If you notice on the table here, you have primary mag stem, secondary, primary current stem, and secondary current stem. So all the frequencies are placed into the respective tables. You probably also noticed that the frequencies that were given through the mag stems were the actual Nogier frequencies. The frequencies that were given through the actual ACS device were the frequencies for the parasympathetic nervous system, from 0.14 to 0.4 hertz. So you can see which ones actually scored a hit there. So now what you do is you have your hits, you have what the body wants, and you need to give this for a period of time. Usually I recommend 20 to 30 minutes at least of exposure. You know, you can go up to 45 depending on the amount of time that you have with the person. When we do belly work with people working on their body or joints, 45 minutes is no problem. When you have your hits, you click on Use HRV Hits. And now what's going to happen is that NeuroField takes you back to the stim setup page. And you'll notice in the stored protocol, the NeuroField takes that table and puts them in a HRV Hits table for you. It's all set up and it's ready to go. So what you got to do now is actually set the amount of loops that you want to do. Click Update, and you'll see the estimated run time. And again, you want to do about 30 minutes, so you could try setting up your loops until you figure out how many you need to get to 30 minutes. I'm going to play around here. Let's see, 125 is too much. I'll try 100 and say OK. So 33 minutes. Remember, the estimated runtime is always going to be less than the actual runtime, so you want to go below the number. So let's try 90. And there's 30 minutes exactly. I'm going to go 80. More than likely 26 minutes. So the actual runtime will go to 30 minutes easily. So once you set it all up here, now you don't need the HRV sensor on a person anymore. You can take it off them and click on Save Stim Setup and Continue. You'll notice that NeuroField has shut off the HRV. You no longer need it at this point because you're ready to go. Click Save Patient Settings and Continue, and then simply just start the treatment. And NeuroField will deliver those frequencies to the person for the amount of time that you set in your lips. And that's pretty much it. That's the HRV procedure. All right, thanks.